Mayang adlaw sa tanan. Welcome to Agric 44 with the descriptive title of Statistics Applied to Agriculture. So I am Junrey Anthony M. Remolio from the Department of Agronomy and Plant Breeding. And I'll be teaching you some technical topics related to Agric 44 that would help you in understanding those basic concepts which will be applied in the future topics that we will discuss. So give me a minute to show you my slides. Okay, I'll be showing my slides. Okay, here it goes. So our first topic that I will discuss is about summation notation. Okay, so what comes in your mind when you hear the word summation notation or just simply the word summation? So for me, summation comes from the word sum, which is the total when you add two numbers. So when speaking about summation, then it speaks about total. So according to a dictionary, that it is an act or process of forming a sum. And in statistics, it is frequently necessary for us to discuss about summation because without making some totals, especially when there are some datas that or some data rather, because it's already a plural, some data wherein we need to get the average, then it is impossible for us to get that amount without summing up all those important values. So that is what we will talk about, the summation notation. So summation notation or sigma notation allows us to write a long sum in a single expression. And it is denoted by a symbol sigma, the capital sigma. It tells us that we are summing something. So let's start with this basic example. Consider that a controlled experiment in which the decreases in the weight over a 6-month period were 15, 10, 18, and 6 kilograms respectively. If we designate the first recorded value x1 and the second x2 and so on, then we can write x1 equals 15, x2 equals 10, x3 equals 18, and x4 equals 6. Using the Greek letter sigma to indicate summation of, then we can write the sum of the four weights as summation of xi, wherein n is equals to 4, the top part, number 4, and then I is equals to 1, where we read summation of xi as I going from 1 to 4. Okay? So the numbers 1 and 4 are called the lower and the upper limits of the summation. Hence, we could read the equation as summation of xi, wherein n is equals to 4 and I is equals to 1 is equal to x1 plus x2 plus x3 plus x4. So consequently, we can now derive those values from the first example, wherein 15 plus 10 plus 18 plus 6 is equals to 49. Okay? So on the other hand, the letter N signifies the number of values in a set of observation. And I means that would be the value wherein you could start including adding up all until the total value. Also, Now, given this example wherein summation of xi, wherein n is equals to 3 and I is equals to 2 equals x2 plus x3. So it would be a total of 28 wherein we add x10, which is the value of the x2 based on the first problem or the first example, then x3 is 18. So when you add these two numbers, then it will result to a sum of 28. So the difference between this equation, compared to the first equation, where it is the n of the first equation is 4, whereas in the second equation it's 3. So meaning your observation that you will include in the summation is until the third n, which means that you will just count until 18. Okay? And then I in the first example is 1. So meaning you will start adding up from the value 1 up to 4 because n is equal to 4. So in this case, you will just start at the second value. So meaning you will start at 10 instead of 15. So you will no longer include 15. So n plus 10 plus 18 equals 28. You will just include you will just add until the third data because n is equal to 3. So 10 plus 18 equals 28. In general, the symbol summation of n and I is equals to 1 means that we replace I wherever it appears after the summation symbol by 1, then by 2, and so on up to n. And then add up all the terms. Therefore, we can write, given this first equation wherein if xi squared, summation of xi squared wherein n is equals to 3 and I is equals to 1 is equal to x1 squared plus x2 squared plus x3 squared. So what if we will change I is equal to 1 to 2 and then the n is still 3? So your equation would be if summation of xi squared wherein n is equals to 3 and I is equals to 2, it will now become x2 squared plus x3 squared. Okay? And then given this second equation wherein summation of xjyj is equals to n is equal summation of xjyj wherein n is equals to 5 and then j is equals to 2, then we can come up with this equation wherein x2 y2 plus x3 y3 plus x4 y4 plus x5 y5. So we can no longer include x1 y1 because according to the equation, j is equals to 2. It's just similar with I. So meaning you will start at the second data. So for example, if we replace j into 3 and then n would be 4. So our equation would be x3 y3 plus x4 y4. Okay? So at this time, we will discuss the 4 types or the 6 types rather of summation notation. So first, the summation. It could be summation of x or summation of y. So the x and y represent the variables. Okay, we could also name it x a summation of z if you want. And then number 2, sum of squares, either x squared, a summation of x squared or summation of y squared. And then third one, square of a sum, wherein we square the summation of x, or square of the summation of y. And then the fourth one, the products of sums, wherein we multiply the summation, the sums of, or the summation of x and the summation of y. And then the fifth one, sum of products, wherein we add the products of the two variables, the x and y. And then the double summation, wherein we could denote it as double summation of x or double summation of y. So what are the meanings of these 6 types of summation notations? Okay, so the summation is a value which is a result of adding all the elements of x, as in one column table or in a single dimension array. Okay, so it's just simply adding all those values in a single dimension array. So for example, given this equation wherein summation of xi, wherein I is equals to n and I is equals to 1. So you just simply add all the values until xn, depending on how many observations, no? So x1 plus x2 plus x3 plus xn. If the set of observation is 5, then you could add all those values until x5. So x1 plus x2 plus x3 plus x4 plus x5. Okay, applying the recent equation example that we discussed, if we change I into 2, and then the n is equals to 5, then we will start adding from x. We will start adding at x2. So x2, x3, x4, x5. So in this case, if the summation of xi, wherein I is equals n rather, n is equals to 5 and I is equals to 1, then we can add 1 plus 2 plus 3 plus 4 plus 5 equals 15, given that these are the set of values or observations. So as you can observe, there are 5 values, the 1, 2, 3, 4, and 5, and that would represent the n. And then, since I is equals to 1, then we will start adding from 1. So if we change I into 3, then n is equals to 5. So we will add 3, 4, and 5. Okay? So that is a total of 12. Summation of x. So this reads as the summation of xi from I equals 1 to I equals n. Okay? The second one, the sum of squares, or summation of x squared, it is the sum of all the squares of the elements of x, or we could also use summation of y. So it is the sum of all the squares of the elements of y. Squaring each value of x, then getting the sum. So in order to obtain this value, given that there are sets of values, we need to get the square, or we need to square first each value and then get the sum of the products, when we square the values. So this reads as the summation of xi squared from I equals 1 to I equals n. So for example, summation of xi squared, wherein I is equals to n and I is equals to 1. So it would be x1 squared plus x2 squared plus x3 squared plus xn squared, depending on what is the value of n. And then square of the sum, or the square of the summation of x, or the square of the summation of y. So it means that the square of the summation of a variable, say x, is the value as a result of squaring the summation of the variable. And the products of sum, or the product of the summation of x and summation of y, means it is a value as a result of multiplying the sums of the variables. And the sum of products, or the summation of xy, means the sum of the products of the two variables x and y is a value which would result from the addition of the products of the values of x and y. So for example, if we want to obtain the values for x and y, then we could solve for letter A, the summation of x. Say for example, these are the values, no? Though there are already answers provided, but at least it will give you a deeper grasp upon which how do those values are obtained. So summation of x is equals to 34. So say for example, no, we are just focusing the values of x. So 4, 5, 6, and 9, and 10. So if we obtain the value of x, then we just add up all the 5 values, and it will result to a sum of 34, and that is the value of the summation of x. So meaning, given these values, so that n is equals to 5. Okay? Because 4, 5, 4, 5, 6, 9, and 10. And in order for us to compute letter B, the summation of x squared, then we need to square each value and before we get the sum. So given this third column, so x squared is equals to 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 9 times 9 equals 81, and 10 times 10 equals 100. If you get the sum, that would be our value for summation of x squared, which means 258. Similar computation with our y squared. And in order for us to obtain the letter, I think it's not included in the letter in the given values to be computed. So in assumption that we would obtain summation of y squared, then you just add the total squares of each value of y. So 3 times 3, 5 times 5, 25, 7 times 7, 49, 8 times 8, 64, and then 10 times 10, 100, then the sum is 247, and that would be our value for summation of y squared. Okay? So in order to obtain the summation of xy, I think it's in letter E, which is 251, then we need to multiply variable x and y. So in this case, we multiply 4 times 3 equals 12, 5 times 5 equals 25, 6 times 7 equals 42, 9 times 8 equals 72, and then 10 times 10 equals 100. And if we get the sum of all those values or of these products, then it will result to 251. And say, for example, in obtaining the square of the summation of x, so first, we will just get the square value, the squared value of the summation of x. So 34, the square of 34 is 1,156. I hope as you study statistics in all the topics, you need to be accompanied by your scientific calculator. That is common sense. So similar computation in getting the square of the summation of y, which is 33, then you just get the squared value of 33. Okay, so it will result to 1,000 1089. Let's try to check. So 1089. And then for letter F, in order to obtain the products of the sum, then we just multiply 34 and 33. So 34 times 33 equals 1,122. Okay. So the last one is the double summation, or the double summation of x, or double summation of y. So it is applied in a two-way table or in a two-dimensional arrays. One example of this is when you tabulate all your data. Say for example, if you have four types of fertilizers and then you replicate it by 3 or 4, then you could come up with values wherein there are rows and columns. Say for example, if you have 4 types of fertilizers, so you could come up with 4 rows, no? which is shown in the next slide. Then given that you need to replicate it 4 times, then you need to come up with 4 columns. So it's a two-way table that is composed of R rows or P rows and C columns or R columns or replications. Okay? So this reads as the summation of xij from I equals 1 to P and j equals 1 to r. This means that the sum of the values of a two-way table with a number of rows is equals to P, and the number of columns is equal to R. Okay? So say for example, given this equation, so the summation of ij, a summation of xij, wherein I is equals to P and J is equals to R, and I is equals to 1 and J is equals to 1, we could come up with this formula. So this reads, this can be read as x row 1 column 1 plus x row 1 column 2 plus x row 1 column 3 plus x row 1 column R. So it would depend on how many column. Huh? And then for the second equation, x row 1, I'm sorry, x row 2 column 1, and then x row 2 column 2, and then x row 2 column 3 plus x row 2 column R. Okay, and the third equation, x row 3 column 1 plus x row 3 column 2 plus x row 3 column 3 plus x row 3 column R. And then the last one, no, it means that if there, regardless or given how many rows, then it is denoted as P, as you observe. And given that how many columns, it is denoted as R. Okay? So, for example, the grain yield of corn applied with different fertilizers. So this is the example of a two-way table. So you will apply double summation. Okay? So there are 4 types of fertilizers. Huh? Say for example, you will use muriate of potash for F1, or say for example, and for F2, complete fertilizer, and F3, amophos or ammonium phosphate, and F4, say for example, organic fertilizer. So these are 4 different types of fertilizer. So in an experiment, in order to minimize the errors, then you need to replicate it. So in this case, in this table, there are 4 replications. So meaning, you are to replicate it 4 times. So as you can see, say for example, for F1, each replications have different values. So when you total all the rows of F of fertilizer 1, then it will result to 12.2. And the mean or the average is 3.05. So how can we incorporate the data or the formula rather? So for fertilizer 1, no, replication 1, this is the X row 1, column 1. So if we add the 4 values, then we could use a formula that X row 1, column 1 plus X row 1, column 2 plus X row 1, column 3 and X row 1, column 4. Because F1 falls on the first row, but the replications are the different columns. So when you add all the 4 values, then we could come up with a total of 12.2. Okay? And you apply the same manner for all the rows in F2, F3, and F4. And these are the results. Okay? So, that is all about the double summation. And that's the summation notation in general. So for your questions or clarifications, first for my Agric 44 students, I believe that we have already discussed this during our orientation. So there are section leaders assigned. So you need to communicate with your section leaders. And they will just be the one to relay what are your concerns. If you want to have a follow-up discussion via Google Meet. And for others, no, which means Agric 44 students in CMU, but I am not your instructor or you are not under me, then you can reach me up through my email at jamremolio@cmu.edu.ph or my Facebook page, Surgeon Updates. And others also include those students who find my presentation interesting from other universities, then you can reach me up through these contact details of mine. So thank you very much for listening, and I hope you've learned a lot. And then for my students, I will try to make another videos discussing the other topics or the other technical topics in Agric 44. So thank you very much for listening and have a great day.